All right, this is the quiz from yesterday in class, and I already have a video in the YouTube playlist that goes over the quiz that we took a couple years ago, and there are only a couple of questions that are different between the two. So rather than recording the entire video, again, I'm going to encourage you to watch the one from a couple years ago, and this is just going to be a supplemental video going over the couple of questions that were not done in the video or in the quiz that we gave last year. So like for example, number 1 is identical to number 1 on the other video, so I'm not going to go back over it. Again, you can watch the YouTube playlist and get that one there. However, this particular question and this diagram is not in the one that is recorded already. So I'm going to go over numbers 2, 3, 4, and 7 because those are, I believe, the only ones that are different on the quiz that you guys took versus the video that's already been recorded. And they're not even that different, it's just a different scenario. So this particular one says use the information and image below to answer the next 3 questions, and then it says 2 carts with a compressed spring between them are held together with a string as shown. When the string is cut, the spring pushes the carts apart. Cart A moves to the left at 5 meters per second while cart B moves to the right. So I know that when these separate, this one's going to go this way and this one's going to go this way. This particular problem is an example of a recoil. And your quiz, the video that we gave them, the quiz that we gave last year had a recoil in it as well, except it talked about ice skaters standing together on the ice and pushing apart. And otherwise, the question here is identical. Because it was actually the same answer choices and everything. So if you watched the other video already, you've already seen this and probably already know the answer, but it says, which of the following is true regarding the momentum of the 2 carts? Again, when you have a collision, regardless of what type it is, whether it's recoil like this one, bounce apart or stick together, we know that in any of these types of collisions, when we analyze our 2 objects involved in the collision, we're going to see conservation of momentum. And so we would not expect anything to have double the momentum or for their total momentum to decrease. We're expecting the amount of momentum to stay exactly the same. And so in a recoil, that means the momentum of cart A should be equal and opposite to the momentum of cart B, since the initial momentum of this system is 0. They start out at rest. And so they need to end up with the final momentum of 0 as well, meaning these have to cancel each other out. The next one says the 2 kilogram cart travels at a lower momentum. Yes, it has less mass, but it's going to move faster as a result. The momentum it has should be equal and opposite to the other cart. And so no, it does not have a lower momentum. It has the exact same magnitude of momentum, which is what D says. Their momentum values are equal but opposite, and that is the answer you should select. If this is true, then this means we have conservation of momentum. The total initial momentum of the system should equal the total final momentum of the system, and since the initial was 0, then that means that these need to have equal and opposite so that they cancel out, giving us a total of 0. So this needs to be true. Number 3, again, on the quiz video that's already uploaded to YouTube, this particular question is presented as a calculation involving a cannon and a cannonball, but it's still a calculation for a recoil. It's just not the same recoil. In this one, we grouped them together with this picture and the information in it. So if you watch that one, that's also a good example. But I'm going to go ahead and work this one out. That way you can see how to solve this particular problem. So let's give myself some space to work. It says, given the information above, how fast does cart B travel? Again, in a recoil and any of these scenarios, you're going to want to start with a diagram. Obviously, we have this here. So I have a before and an after. So I have my 2 carts that start out together. And then after the collision, or in this case, the recoil, sometimes it's an actual explosion, they're going to be moving apart from each other. Okay, and so you have the before and after. And you can label the objects, 1, 2. On this one, they're A, B, 1, 2. And we can label our givens. So M1 is going to be the mass of the bigger cart here, which is 6. M2 is the mass of the other one, which is 2. Those masses aren't going to change, so M1 and M2 over here are still 6 and 2. But the velocities will, because the initial velocity of object 1 is 0. The initial velocity of object 2 is also 0. Before the spring pushes them apart, they're at rest. Or before the cannon fires, they're at rest, if you're looking at the other one. And then over here, V1 final, it tells us in the question that cart A moves to the left at 5 meters per second. That to the left, I'm going to call the negative direction. Again, at the beginning of the year, we talked about the fact that anything to the right was positive and anything to the left is negative. We did the same thing with up and down. Up was positive, down was negative, just like a coordinate system in math. And this sign tells us left, so you do need to include signs here. That's the only way you can get this equal and opposite thing, okay, is that you label one of them with a negative sign. And we're going to stick with the convention that we used at the beginning of the year. V2 final is what we're looking for because it asks how fast cart B travels. So with this, we can go and we can plug into the conservation of momentum equation, which is M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. And when we substitute in with numbers, this is going to be 6 times 0, that's going to be 0. This is going to be 2 times 0, that's also 0. Again, if you have a recoil, there is a shortcut because you do start out with 0 momentum at the beginning. You could go straight to the shortcut if you want. M1 is 6, V1 final is negative 5 since it's to the left, plus M2 is 2, and then we have V2 final that we're solving for. All right, this is going to be negative 30 plus 2 times V2F equals 0. Again, we need these to be equal and opposite, which means if this is negative 30, this needs to be positive 30, or algebraically speaking, if we're wanting to solve, we need to move this to the other side. We can do that by addition. 30 equals 2 times V2F. Divide both sides by 2. And we have that V2F is equal to 15 meters per second, specifically positive 15, since it is going in the rightward direction. All right, so the answer to number 3, therefore, should be answer choice A. All right, again, this is similar to the cannon problem that's worked out in the other one. This particular problem here is similar to the scenario that is described in the other video about a car hitting a semi-truck. We've also done examples in class about a bug hitting my windshield, things like that, where you have two objects that are of different size, and yet we ask things like which one has more force, which one has a greater change in momentum, which one has a greater acceleration, things like that. In fact, those other questions, I believe, are actually in the other video. They're not on this quiz, but they were in the version that we did last year. So this one only is asking about a comparison of the forces. How does the force on cart A compare to the force on cart B during this collision? Now, obviously, cart A and cart B are different sizes, not necessarily as drastically different as a car versus a semi-truck, but different sizes. They have different masses. However, that does not affect your answer to this question. The forces will still be equal and opposite. Even though their masses are different, it's still a force pair. We still apply Newton's third law. So the force applied to cart A is equal and opposite to the force applied to cart B. It's a force pair. Now that does mean that they have different accelerations because they have different masses, but we're not being asked about that here. Instead, we're just being asked to compare the forces. If you watch the other video, again, they go over, or I go over in that video, the difference in the acceleration as a result of the different masses. And you're welcome to watch that because that is something you should know as well. Again, these next couple of questions are identical to what was on the quiz that is already recorded from last year. So let me skip down to the next one that's new, and that is number 7. And there was not a problem like this at all in the quiz. So the other ones, they were very similar to questions from the quiz, but this one, there was not an example of a stick-together collision, and so we added one this year. It says, ball L rolls with a velocity of 4 meters per second toward a stationary ball R as shown below. The two collide and stick together, which describes the velocity of the two objects after the collision. So they do tell us that this is moving 4 meters per second and that this one's initially at rest. Okay, and then they ask about the velocity afterward when they stick together. Obviously, when they stick together, the two of them together have a larger mass than either of them does individually because it's the sum of their masses. Now, we could actually solve this problem using conservation of momentum, but we don't have to answer it. Okay, if this one hits this, it's obviously going to transfer momentum to object R, so object L is going to have to slow down whenever it does that because now they're both moving and it's the same momentum moving a larger amount of mass. And so I know that whatever speed this is, it's less than 4. It has to be. Okay, and so if we look at this, the options say they will move together with a velocity that is less than 4 meters per second. That is 100% true. They will have the same total momentum together as ball L did initially. That is also true. Because, again, conservation of momentum states that my total initial momentum equals my total final. And initially, this one has no momentum. So this momentum is the amount that we're sharing over here. And the total momentum of these two objects together once they're moving after that collision has to be equal to what we started with. Otherwise, we're not following conservation of momentum. And then it says they will move together with a velocity of 4 meters per second. Again, that can't be true because if they did that, there would be more momentum at the end than what we started with since there's less mass here. Okay, so it's A and B both are correct, which is answer choice D. Again, you could solve it. If you're solving it, M1 V1 initial plus M2 V2 initial equals, and then here's where it looks a little different anytime you have a situation where you have stick together, because there's no V1F and V2F, there's just VF. When they stick together, they move at the same final velocity. Okay, and so you would still have M1 times VF plus M2 times VF, but because these are both VF, these are like terms, and so you could factor it out, and sometimes you'll see it written this way, M1 plus M2 times VF, and it would still be equal to this. So this is kind of a shortcut for stick together. If you wanted to actually solve it to figure out how fast they're moving, you could. It will be less than 4, but this would be the equation that you could use for a stick-together collision, and it's what you should get whenever you go through solving it. Even if you start here, you need to recognize that those two are going to be the same because they are literally stuck together. Okay, and so that makes these like terms where you can add them. All right, so again, that's how you're going to do number 7. Now, in the video that I recorded for the quiz from last year or 2 years ago, I mention information about other things to look at, and I mention information about the free response question. In that video, I say that there is a choice that you're going to be given for free response, and that is what we did 2 years ago, but it is not what we're doing tomorrow. Your free response question that you're going to be answering tomorrow is going to be similar to the second one that I talk about in that video, where you're dealing with just energy and looking at a scenario. I related it to the problem with the skier going down the hill from my open math, so that would be a good one to look at. But it's not going to be similar to the one that you took in class on that little half sheet, like these right here. We did these types of ones in class. It's not going to be like this where you have a collision to analyze and energy to work with. So it won't be like that. It'll be like the where you're just using conservation of energy, at least for the first question. There is a second one that involves momentum, but they're not actually grouped together. So I just wanted to mention that because the other video does talk about what the free response, and although we did it like that a couple years ago, we're not doing it like that this year. So hopefully that clears it up. Again, there's also a video of me going over these warm-up quizzes, so that would be another good thing to look at. And of course, you have a unit summary, and you have problem sets in My Open Math that you can do in practice mode. You've got a lot of things that you can use for review, and I would recommend that you do that. Or if you need to stay after school for tutorials, obviously we'll be here for that too.